Okay, so the curve has the equation y equals 2x squared minus 11x plus 13. And we are told the point P, which is 2 minus 1, lies on this curve, and we want to find the equation of the tangent at this point. So a little sketch, as we've done before, will help. Tangent at that point P, and it's got coordinates 2 minus 1. So we know, of course, now we've got a coordinate, which is great to work out the equation, but we also need the gradient, yeah? So the gradient we get by working out the derivative, so dy dx, which is 4x minus 11, okay? We differentiate this here, yeah? So then at the point P, okay, at P, dy dx is equal to 4 times 2, take away 11, which works out to be negative 3, okay? So this is the gradient of the tangent, okay, negative 3. Now we want the equation of the tangent, so quite simply, the equation of the tangent will be y minus y1, we use the equation of a straight line, equals mx minus x1. So we put in the coordinate, we put in the gradient, and we get then this becomes plus 1, yeah, because 2 minuses make a plus, minus 3x, and then plus 6. Minus 3 times minus 2 is plus 6. So this becomes y plus 3x equals to 5. So there is the equation of the tangent. So that's part A answered. In part B, they say the point Q lies on the curve C and is such that the gradient of the normal to C at Q is minus 1/9. Find the x coordinate of Q. So again, a little sketch will help. So suppose we've got this point Q, and they are talking about the normal. Of course, we know about drawing the tangent there, and then the normal will be at right angles, will be perpendicular to the tangent, yeah? Now we're told that the equation of the gradient of the normal, okay, and they've bolded it there for us to realise that the gradient of the normal is minus 1/9. Now, of course, when it comes to dy dx, and of course we know in this question dy dx is equal to 4x minus 11, dy dx is the gradient of the curve, but also the gradient of the tangent, right? We haven't got that, we've got the gradient of the normal. So if I use, because they're perpendicular, if I use m1 times m2 equals minus 1, put in the normal, okay, I can work out then the gradient of the line that is perpendicular to the normal, which is the tangent. So we'll take the minus 1/9 over. Okay, so if we divide that, obviously bottom, fraction on the bottom means the very bottom number comes up to the top. 2 minuses make a plus, so we've got 9 out. So 9 will be this gradient. It will be, in other words, the gradient of the tangent is equal to 9. So in other words, dy dx is equal to 9 at the point Q. Remember, dy dx is the gradient of the tangent. So dy dx is equal to 9. And of course then we know, we've already worked out dy dx, haven't we? It's 4x minus 11. So we can set that to equal 9, work backwards, and you get your x value. So we get 4x is 20, so then x will be 20 upon 4, x will equal 5. That's what they asked for. So we know now the x coordinate at point Q is 5.